Hello, how you doing? In this video, I'm going to talk about Pinecone indexes. Have you heard the term Pinecone Index? And you're not quite sure you know exactly what this is. Well, if so, then watch along with me for the next few minutes and I'll quickly get you up to speed. Okay, let's get started. I wanted to first talk to some Pinecone terminology. In relational databases like MySQL, Postgres, etc., rows live in tables. In Pinecone, what you might think of as a table is called an index, and what you might think of a row is called a vector. I'm going to be using this term index quite a bit, and I wanted to make sure you knew exactly what I was talking about. Now, with this terminology covered, let's move on. What do we need to do to get going in creating a Pinecone index? Well, first we need to create a Pinecone account, and second, we need to get an API key. You can do this by going to the Pinecone website and signing up for an account if you don't have one, or logging in if you already do. Once logged in, navigate to the dashboard, select the project. On the dashboard, under your selected project, look for a section labeled API keys or a similar option in the navigation menu. If an API key has already been generated, you'll see it listed here, and you can copy it by clicking on the copy button next to the key. If you need to create a new API key, there should be an option to generate a new key. Click on it, name your key, and generate it. Once the key is generated, copy it for use in your applications. In this video, I'm going to be showing you examples in Python, but you can integrate to Pinecone natively with a variety of languages. In addition to Python, Pinecone has SDKs for Node.js, Java, .NET, Go, and Rust. In any language you use, you'll first need to download the respective Pinecone client library. In Python, you can do this using pip install to download the Python library. The Python code I show you can be executed using a Jupyter Notebook or any Python code IDE, such as Visual Studio Code. The first thing you'll need to do as you follow along with me in your Python code is import OS, time, and some important Pinecone classes. This brings your dependencies into the Python runtime. Next, you need to instantiate a Pinecone object and you pass it your API key. The client Pinecone object will use this API key on REST API calls to the Pinecone backend in the cloud. Now, let's create an index. Next, you will call the pinecone.createIndex where you provide a number of parameters. Let's quickly go through each one. The index name is self-explanatory. This is just the name of the index. The second parameter is the dimension of the vectors you will store in the index. Common values are 768, 1536, or even greater. Later in this video, I'll cover what might drive your decision on your vector dimension values for your indexes. But for now, let's move on. Next is a metric parameter. This is a distance metric used for similarity searches when you perform queries on your index. The default is cosine, but you can also use Euclidean or dot product. I'll go with cosine. If you're unfamiliar with the basic mathematics behind these similarity searches, I have a video covering similarity search metrics where I break it all down for you. I'll share this link at the very end of this video in case you're interested. The last parameter is a serverless spec, which directs Pinecone to provision your index in a specific cloud provider and region. This could change in the future, but my experience is when using the Pinecone free tier, Pinecone will direct you to AWS and USD Swan when you create your index. With a paid account, you can create your index in Google Cloud Platform, Microsoft Azure, or Amazon AWS. Quick note, you will notice in the Python code that the Pinecone index creation call is inside an if block, which first checks to make sure the index does not already exist. If the index does exist, it skips over and doesn't try to create again. Pinecone index creation takes a few seconds to complete after the Pinecone call returns. So I iterate through a while loop waiting for the Pinecone Index to get a status of ready, and once this occurs, I break out of the loop and print a message to the console indicating the index is provisioned. Now, to watch your wallet, you may consider deleting the index after you finish using it, as you will be charged for the amount of time your index is provisioned. If you have a small amount of vector data in your index, your bill will be small, but it's a good habit to clean up after you're all done. Here's a cautionary tale. Not with Pinecone, but with another cloud provider years ago, I provisioned a PostgreSQL database with several read replicas, forgot about it, and then got a nice little bill at the end of the month. I learned the hard way on the costs of not cleaning things up after you're done. The cloud provider was cool about it and worked with me, but still, this was not me on my best day. So please heed my friendly advice on this. Before we wrap up, I wanted to circle back on what might drive your decision for your Pinecone Index dimensionality parameter. If you recall, I had set the dimension to 1536. To some of you, that may have seemed kind of random, but it's not. A common use case of sourcing vectors for your vector database is to use an embedding model, which can take in text, images, or audio as input and generate output vectors, also known as embeddings. Embeddings are n-dimensional vectors. If this is what you're doing, depending on which embedding model you use, you will want to use the output vector dimensionality of your embedding model for the dimensions parameter when you create your Pinecone Index. In my case, one of the OpenAI embedding models I play with generates vectors with 1,536 dimensions. Different embedding models generate output vectors with different dimensionality, so if your use case uses vectors from an embedding model, check out the dimensionality of the output vectors for that model you're using and use that as your dimensions parameter when you create your Pinecone Index. Okay, you should now have basic understanding of Pinecone indexes. In upcoming videos, I'll be showing you how to perform vector upserts and deletes, as well as vector fetches and queries. Check these out to see how easy it is to do CRUD operations on Pinecone indexes and to get a full understanding of how you can leverage Pinecone in your LLM-driven systems. Okay, thanks for watching. This video, along with all my other videos in the Vector Databases playlist, are listed in YouTube description. I invite you to watch other videos on my channel. If you like the way I'm sharing this content, please consider subscribing. When you subscribe, this really helps my channel grow. One last thing. We all love technology, and we're all excited about all the innovation with the cloud and machine learning AI. But don't forget to carve out some time to live in the real world. Go outside, go swimming, go hiking, go climbing, go surfing. Get out and move your body. And if you do, tell me in the comments. I want to hear about it. And with that, have a great day. Thanks.